Live sound reinforcement jobs often begin just like this: an early morning, an empty tent, and an empty stage. Within a few short hours, though, this area will be filled with people listening to live music. But without a sound reinforcement system, there won't be much to listen to. So let's follow the process as an experienced sound crew goes from setup to sound check in this field segment of live sound reinforcement. Every live sound job starts the same way: getting the gear off the truck. For this event, the crew has rented a truck with a dolly lift, a big help considering the amount and size of gear they'll be moving today. Once each case is offloaded, it's pushed into the general area at the stage where it'll be used. Getting the gear to its approximate position now will make the task of setting up a lot faster later on. Down comes the front of house console, the biggest piece of gear on the truck. Notice how the crew is placed around the lift to make sure the case gets let down safely. The ground is wet and makes it difficult to handle the weight of the case. It takes 4 crew members working together to get it off the truck and pushed all the way to the front of house position under the tent. One case after another, the load-in continues, despite the early morning rain. It's not just for the protection of the gear. Packing cases allow the sound company to move a lot of gear very efficiently. The crew makes steady progress. So far, the load-in has gone smoothly and on schedule, with only one minor injury. What's important to notice here is that nearly all the gear used by the company is packed inside anvil cases, and each case has handles and wheels. Anyone responsible for moving sound gear should consider doing the same thing. The crew begins setting up the PA. They start with the main speakers. The upper speaker cabinets slide onto wooden blocks set in the fly-track rail on the top of the lower speaker cabinets. This helps prevent any movement of the top speakers due to the vibration produced by the subwoofers and the cabinets beneath them. The top cabinets each contain a single 15-inch low-frequency speaker in a horn-loaded enclosure, a 10-inch mid-range frequency speaker, and a 2-inch exit compression driver mounted on a horn. The bottom cabinets each contain 2 18-inch subwoofers. The next issue is power. Because today's event is outdoors, power is being supplied from a diesel-powered generator, and the only way to connect it is to drag the lines there. 2 power snakes are hooked together to make the distance from the generator back to the system amp racks over 100 feet away. The generator is kept as far away as possible from the stage due to the noise and the smell of fumes. For this generator, the engineer makes 4 connections. First, he connects ground, which is green, then neutral, which is white, then the red and black connectors, which are hot. These connections will provide 2 120-volt legs of power back to the distribution box, which in turn will make available over 200 amps of power for use by the sound system. On the way back to the stage, the engineer checks the power lines. He knows that maintaining a lifeline with the generator is the only way to keep this show up and running. The AC power lines from the generator have been run back and connected to a power distribution rack or distro box here at the back of the stage area. The distro box provides 6 20-amp circuits via these Edison plugs, as well as these 5 double 30-amp circuits in the lower row. Notice that all 3 amp racks, as well as the master panel, are located behind the main speakers next to the stage. From this one central point, all the power and signal lines will be fed throughout the system. The first rack contains the power and crossovers for the monitors. The third rack contains the house amps, which power up the subs, lows, mids, and highs in the main speakers. The second rack is also a house amp rack, but will be used as a standby unit today in case problems arise with an amp in the third rack. This is a close-up of the back of rack 1, which powers the system's bi-amp stage monitors. To streamline the setup process, the input and output jacks have been wired out to this connector plate. Here is the crossover input. the stereo crossover outputs, the individual amp channel inputs, and the biamp outputs, which combine the two amp channels into one connector. Here on the front of the rack, you can see the 4 power amps and digital crossovers. The amps are run in stereo, with one channel of the lower amps powering the woofer and the monitor, and one channel of one of the top amps powering the horn in the monitor. With total wattage of the monitor amps at 500 watts into 8 ohms, there's easily enough power here to run 4 separate stereo monitor mixes. For today's event, 3 snakes will be run from the stage area to the front of house: a 52-channel input snake, a 16-channel return snake, and a 30-amp power circuit line. Let's take a closer look at these 3 snakes to see how power and signal is run between the stage and the front of house. Let's start with the power line, which is marked in red. The shorter red lines show the amp racks connected to the distro box. The longer red line is a separate 30-amp feed which is run to the front of house area. It provides power to the console, the effects rack, and the drive rack. Using the same source to power the entire system will reduce grounding problems. The second snake, marked in green, indicates the input signal flow. Getting the input signals from the stage to the console is a 2-step process involving a master panel. The master panel is a large connector box next to the stage, which is divided into 2 parts, an input section and an output section. Microphones and direct boxes are connected to 3 12-channel subsnakes placed on the stage. These 3 subsnakes are then connected to the input section of the master panel. The inputs on the master panel input section are wired to a VEEM connector, to which the 52-channel snake attaches. Here's a shot of the input and output side of the master panel, with the 52-channel snake connected to the input side. The long green line indicates the 52-channel input snake carrying the inputs from the master panel directly to the inputs of the console at the front of house. This is how all the mic signals are fed to the console from the stage. The third snake, marked in blue, is a 16-channel return snake that brings the processed signals, the sub, low, mid, and high frequency outputs from the crossover, back to the output section of the master panel for distribution to the amplifiers. The master panel makes these 16 channels in the return snake available in 2 rows of 8 pairs on the output side. Sound engineers often use the word pairs when referring to a snake, such as a 16-pair cable or a 12-pair cable. This is because each cable in the snake has the capability to be wired with 2 connectors, a male XLR output connector and a female XLR input connector, thus a pair of connectors. Wiring one cable for a pair of input and output connectors allows signal to be routed back through the snake to the other end if necessary. To complete the connection of the output signals to the amps, a smaller 12-channel snake is then connected from the output section of the master panel to this VEEM connector on the back connector panel of the amp rack. The 8 outputs carried by the 12-channel snake are then broken out to this row of connectors. They correspond in order to the 4 stereo amp inputs of the amps in this rack and are connected accordingly. These are the 4 amps that will power the subs, lows, mids, and highs. The outputs of the amps to which the speakers are connected show up in 2 configurations at the bottom of the rack, NL4 connectors and NL8 connectors. The NL4s contain 4 individual conductors, which can run 2 different amplifier channels down one 4-conductor speaker cable. The NL8 contains 8 conductor wires, which are wired to all of the amplifier outputs in the rack. This way, all the amplifier outputs can be routed to one cable to a 3-way or 4-way cabinet. To connect to each amp independently, the NL4 connector is used. To connect the entire speaker stack, the NL8 connector is used. There's a second NL8 connector on each side, left and right. These jacks are parallel to the first NL8 connectors to provide a second output for multiple speaker cabinets. The third rack contains the 4 main system amps. This bottom QSC drives the subwoofer. The QSC above it powers the lows, the BGW GTCs power the mids, and this one powers the highs.
I can pretty much tell you right now, as far as running the 12 pairs and everything for the returns, it's going to be sub, low, mid, high, low, mid, high. First monitor, second monitor, third monitor, fourth monitor.
You're doing this in stereo?
Oh yeah.
It's very important that the sub, low, mid, and high output signals be connected correctly at the amp inputs, or serious damage to the speakers may occur.
Thank you, sir. You got it. So subs are going to be in mono, right?
Correct. Patching is going 1, 2, 3, 4, sub, low, mid, high.
With the clock ticking, the crew works steadily to get everything connected at the stage.